Okay, in the part 3, we talked about how much solar insolation can be collected on a panel located on the ground, except we did not talk anything about its orientation, although we kind of briefly mentioned how it is oriented to collect the direct normal radiation. So that is what in this section we talk about the orientation of the panel. Excuse me one second. Orientation of the panel on the ground to collect the maximum radiation on the earth. So as you have seen this before in your part 1 of the solar energy, how the different parts of the year where the sun's location is with respect to the earth, and this is simply representing as the earth goes around the sun and where the different parts of the globe are given the sun's location. And this is the winter solstice, for example, and then this is the vernal equinox and summer solstice here and the autumn equinox. And the tilt, the maximum tilt of the earth towards the sun varies between 22 degrees to about 24 degrees. So on the average, we can talk about the declination angle. This is referred to as is plus or minus 23.45 degrees during the year. So if you plot declination angle through each day of the year, it varies from anywhere between minus 23.45 to plus 23.45. And this you have seen it before, and so with respect to the geometry, so I am not going to talk about that any further than that here. Now this is, for example, how the sun moves throughout the year, and this is the north and this is the south, and this represents for example a house. In fact, this is the picture of a house we built at Florida State University to experiment with various energy systems. And you can see when the latitude is 0 degrees north, very close to the equator, and the position of the sun follows in the summer this path, and in the winter it goes around this, and in the equinox the sun follows this path. So what you can see is close to the equator, you see sun is pretty much on top of your head most of the time, and it moves from east to west. So the orientation of the panel in this particular can be horizontal. So it collects the most of the radiation when the panel is horizontal in this particular case. Now when it is latitude is about 45 degrees north, and you can see that now it is not on the top of the head anymore, and this is during the summer, same 3 different times during the year. This is in the winter, and you can see now the panel has to be oriented in the southern direction, and at an angle of 45 degrees it will give you the maximum radiation. I will show you the plot of how the insolation varies when the plate is oriented at this angle at 0 degrees and 90 degrees. And now in the 90 degree north, right, for example, near the North Pole or the South Pole, and you can see sun is pretty much going in this direction here. That's why summertime you see a lot of light, and the winter time you see no light at all. So essentially when it is completely dark when you are here, and there is a lot of light when you are on the top direction. So in the for example in Stockholm, your latitude is about 59 degrees. So your tilt of the panel has to be around 59 degrees pointing towards the south. These are the local coordinates for the panel. So this is the west and this is the east, and this is the north and south axis, and this is the location of the sun here, and this is the solar altitude angle, which you would know, and this is the zenith angle, and this is the azimuth angle. So the 3 angles which are important to determine the location of the sun at any given time of the year in a place on earth is given by these 3 angles. And in knowing these 3, you can exactly determine where this sun's location is. When once you have that, and this is for example with the panel, in this particular case the panel is oriented right here, and this is your panel at an angle of beta to the horizontal. This is the horizontal, and this angle beta is it turns out to be the latitude angle. And so when your radiation is coming in this direction here at an angle theta. So here south tilted surface, this is what we are doing with a tilt beta at an latitude of phi has the same incident angle of theta as a horizontal surface theta minus b. That is what this thing is explaining. So this is the, again you can, if you orient it this way, then the normal to the panel is this, and the beam radiation is coming, and theta will be like this angle right here. So typically what we want to do is we want to put in an angle, and that angle is the beta, which is the latitude angle. So this is very important. So you orient in the northern hemisphere, you orient the panel facing south at a latitude angle, and that gives you the maximum radiation. And so these are the what is called the collector coordinates in this particular case, and this is your collector, and this is the angle with respect to the horizontal, and these are the different angles which we have to represent. This beta is the collector tilt angle, and this is the azimuth angle here, and these are the axes of the A1 and A2. These are the subscript A1 and subscript A2. These are called the axis orientation, and this is how you know these coordinates, and then you can calculate the radiation coming onto the surface. And this is an experiment which was done to see the inclination angle effect throughout the year, and this was taken from the Beckman book. And you can see this is in Wisconsin, where the latitude is about 45 degrees in this particular case, and the gamma is 0 degrees, and you can see when it is horizontal located, that beta is equal to 0, and you can see, of course, during the summertime the sun is reasonably on top of your head, you get the maximum radiation collection in this particular case in terms of the megajoules per meter square or watts per meter square, and you can see the maximum collection takes place during the summertime, and during the winter time, and the radiation is quite small. In fact, there is almost reduction of about more than a half. So when you put the panel in the latitude angle, and this is what is given, this is the panel in the latitude angle here, and if you look at the area under this curve, which happens to be the maximum compared to any other angle which you have plotted, this is at 90 degrees, and this is at 45 degrees, this is at 60, and this is at 30. So essentially what you are doing is you are orienting the panel at different angles with respect to the horizontal, and it turns out the most maximum collection takes place when the panel is oriented at 45 degrees, which happens to be the latitude angle at this particular location. So the message here is essentially for the photovoltaic panels, you orient pointing to the south, so they all have to point, I can write, I am writing with the point in this particular case to south and at latitude angle. This is not quite right, but that is that is the message in terms of the orientation. So now we have found out how to calculate the insolation hitting the panel. Now we know the orientation of the panel with respect to the sun. So by knowing these two things, we can essentially, and knowing the area of the panel and the efficiency of the panel, we can calculate how much energy we are collecting during the day, and by that you can average during the month and then average it further to get annually. So what we now do is, knowing all this, now we have to go into details of how these solar cells work and how the panels are put together and to generate the required power. So that's what we will do in the next lecture. We will talk about the photovoltaic cell and its structure and its performance.